Hello everyone. In this video, we will learn how to compute the size of periodic payment for ordinary simple annuities when present value is given. So in this problem, Tim obtained $60,000 loan today, and therefore that's the present value, $16,000, and then he is to pay back this amount through monthly payments for the next 6 years. So payments are monthly, and therefore the number of payments in 1 year represented by PY is 12. Interest that is charged on this loan is 3.6%, and that's a nominal interest rate, J. Interest is compounded monthly as well, so that makes it 12 compounding periods per year. So as you can see, the number of compounding periods per year is 12. That's interest. The number of payments per year is 12. These two numbers are the same, and therefore that makes it a simple annuity. Okay. There are different ways to calculate the size of payment. One would be using a financial calculator, or you could use formula. You can calculate manually, and or you could use Excel. Okay. If we wanted to use formula as well as Excel, we need to find the periodic interest rate. Okay, so we need to find I, which is the nominal interest rate divided by the number of compounding periods per year. Also, we need to find the total number of payments. So first off, this rate here is interest rate per payment period, which for simple annuity would be interest per compounding period, okay, because these two periods are the same. And N is the total number of payments, okay, so that's N is total number of payments. In the term, okay, so when I say term, it means that this loan term, which is 6 years. So now N is the number of payments in 1 year multiplied by the number of years in the term, which is T. Okay, so now let's enter these numbers into Excel. So our PV is equal to 16,000 because it is received today. If we want to follow sign convention, because it is a cash inflow for Tim, then it is positive. Interest rate is 3.6%. Number of compounding periods, 12. Number of payments per year, 12. And T, which is the number of years in the term, is 6. Next, periodic interest rate is the ratio of J, the nominal interest rate, and M, which is the number of compounding periods. Because we're going to be using division here, we need to use equal sign first. Now J is in B9, so we click on B9, and then we use a slash for division, and then we click on M, and there you go. You press enter, and it calculates the compounding interest, or interest per compounding period. The number of payments in the term is equal to, we're going to use the equal sign because we're going to be using the function multiplication, right? So this is equal to PY multiplied by T, which is in B12, and press enter. 72 payments in 6 years. Now, in order to calculate PMT, we're going to be using the built-in function in Excel, so we have to press equal and then type in PMT. And here is the function. As you can see, the input arguments are rate, N, PV, and type. So rate is I is in B14. Then you type in comma, then the next variable is N, which is 72, then comma, and PV is in B8. Now, this is a PV problem, so FV, you don't have to input FV, and type is for basically a type of annuity, if it's ordinary annuity or annuity due. The default is ordinary annuity, so you don't have to input anything for those two. All you need to do is just close bracket and press enter. And as you can see, the size of payment is $247.42. The reason that 247.42 is in red and it's in round bracket is indication that it's a cash outflow. So you could use this sheet for any ordinary simple annuity, even to find PMT. For both cases, if PV is given or FV is given. This portion are the input variables that change from one problem to the other. Everything else will be calculated automatically.